Hello civil engineers, welcome to my YouTube channel, and today I will show you how to add loads combination to your analytical model and to add and to assign loads in Staad Pro. Okay, so although in our locations we are normally not having prone to earthquake, but I'm going to do even earthquake seismic loads for my viewers. Okay, so let's begin. So please watch this video to the end. Don't mind my accent, but mind my content, because if you watch my videos to the end, we are really going to benefit, and it's mutual. So I think if you subscribe, you support me, you like my video, then I will have more good content for you. So let's start. So you can see my analytical model here, and here is my 3D rendering. So I have modeled my structure right here. Okay, so I need to assign loads, so I will go to loading, and so I will expand that one. So the first thing I will add is wind, so I will go to add. So I will add wind 1, add, then close. Then I will just again highlight. I will click wind definition, then add. Okay, then add. Just okay. Now I need to generate wind. I will just generate using the ASCE. So calculate as per ASCE. Then my exposure will remain as it is here. So this is the basic. So I'll go to data. Then I will edit here, because my building height is 14.25 meters. And then this one I can leave it like that because it's just around there, just somewhere close to that. Then this one I will leave it like that, partially enclosed. No, I will enclosed building, and then I will apply. Then I will go to building design pressure, windward. Here I will not change anything. Then okay. So I have generated. So I will add, and then my factor for exposure. Now I will use 1, and then I will add. And then this one, now I will assign to view. Very important, don't forget that. So I will assign that one to view. So you can see my nodes have been selected, so it means I have assigned to view. Now I will go. So also my area we don't have snow, so I will prepare a video on that. So we will go to Seismic. I will add. So we'll use we want to use the British codes, but as I have said before, in our location we don't have a lot of issues with earthquakes, so it's very rare to design for earthquake in our location. So I think I will just use the US code 2015. So I just use the ASCE. Then just add. Then I will close. Then I will come, select that, add, and come to self weight. There is nothing like there is no negative in Seismic, so self weight will be 1. Add. So my laptop is just misbehaving, but just bear with me. So I will add Seismic. So I've added twice, so I need to delete this one, delete. Then I will continue to add. Then I will add member weight. For member weight, I will choose uniform, and then we want to calculate the unit weight of my walls. And you can see I'm using 200 millimeter brick wall. So let me show you my architectural. Maybe it's this AutoCAD making my laptop to somehow hang and misbehave, because AutoCAD is usually utilizes a lot of computer memory and RAM. So you can see the position of my walls, and from the architecture, I'm supposed to use 200 millimeter brick wall, 200 millimeter thick interior masonry wall. So you can see where my walls are located. Just this is the first floor, this is the ground floor, this is the first floor. You can see I have wall here, I don't have, here I don't have, there I have parapet wall here, because this is balcony. And then I have another wall. So see, this side is similar to that, and of course I've designed halfway the model, and I explained this in my other video, so you need to go and watch it, so I will not repeat that. So here we don't have a wall here. Of course we have wall on the outside, on the wall, then we jump to beams, then wall, jump to beams, then wall. Okay, so I will go to my Seismic. I was here, then I will expand that, then I will add. First of all, we need to calculate. So we have the calculator here. Wait, my computer is misbehaving. So design, go to utilities, calculator. It won't open calculator. Okay, I'm going to try this. Calculate. So you can just let us see. Okay, so I need to cancel that, cancel that. So my calculator has finally accepted. So we have a 200 millimeter thick wall. So 200, I will use standard scientific. 200, so it will be 0.2, that is the thickness, 0.2, then multiplied by the height. So as you can check here in my beams, I have beams of height I have 450 millimeter. 450, I am using 450 from my model. So I will go here, multiply by, so my story height is, if you check, let me node to node distance. So I want to check my story height. My story height is 2.85 minus 0.45, so it will be times 2.4. that is the story height, 0.2.4, and then multiplied by I will multiply by my my characteristic, my unit weight of masonry. So I will use 20. So is equals. So my wall is 9.6. That is my external wall, external and internal wall. So the other thing that I need to calculate is my my parapet wall. So my parapet wall will be, I'm using steel 0.2 multiplied by now 1 meter, 1 multiplied by 20. So for my parapet wall will be 4. So let us add those weights. So just need to click shift, then okay. So let us add the loads for sorry, add. So member weight, remember there is no negative in Seismic. So I'll start by adding the wall, external wall, which will be 9.6 kilonewton per meter. Then add. Then I will add for my parapet 2.4, 4 kilonewtons per meter. Then I will add my floor loads for my slabs. So let's go back to our calculator. I'm using a slab of 150, so 0.15 meters depth, so 0.15, and then I will multiply that by the characteristic strength of concrete, 25, and so the characteristic strength of concrete is 3.75, and then you assume finishes, there are finishes of 1.5, so I will use 1.5 plus 0.75 plus 1.5 is equals 5.25. So I have a pressure of 5.25. Then my range is between 2.8 to 11.4. Right, let's say 11.41. That is my Y range. Then I will add. Then I will add for live load. My live load is 4. My range is from there still 2.8 to 2 for this up to. So let me show you the architectural. So here I'm having classrooms. Okay, this is a classroom, and this is the roof slab, which is not accessible. So I will not use the same live load for roof. So I will just use live load for classroom for all these, but this one I just use 1.5 for regular. So this one is 4, and then the height is 2.82 times 3, so it will be around 11, around 8 point. Let me check. So let me check node to node distance. So I want to check from here to there, 8.55. that is my range, to 8.56, then add, and then I will add 1.5. My range will now be 11.4.39 to now the up to the say up to this water tank. So up to, let me check node to node distance. That point 14.26, let's say like that. Add. Remember this one should go up to also the roof. No, this one is water tank, so we should calculate the weight of the water tank plus the unit weight of the slab. So let's assume a 3000 liters tank, that is 3000 kgs multiplied by 10 is equals divided by 1000. So we find that the weight on that slab will be 30 kilonewtons per meter. Okay, because 3000 liters is 3000 kgs multiplied by 10 is equals to 3000 newtons divided by 1000 is equals to 30 kilonewtons. So this is the weight of the water tank, 30 kilonewtons, and then we need to divide it by the area of this slab. So node to node distance. So I'll go here and check node to node distance so that I can find the area and then divide that by this area. So that is 4.4. This is 2.6. So 30 divided by into bracket, I need let me delete this. Two. So I need to delete this. So it will be 30 over let's just say 2.6 times 4.4. I mean, sorry for that, 2.6. You can't add point by keyboard. So times 4.4 is equals, so 11.44. So we're going to do 30 over 11.44 should be equals to, so my water tank will be 2.62337, but yeah, that will be the water tank. So plus this one plus 5.25. Now the dead load on the water tank will be 7.9. So we'll go and add 7.9. Cancel. Now it will be 7.9 7.9 range of be 14.23 to 14.27, then add, then close. So I think we can now check just to confirm. Check just to confirm. Yeah, that is okay. That is for live load in the roof and the water tank. Now live load for the normal slabs, which are the classrooms, first floor, second floor, and third floor, and then dead weight, I mean unit weight of slab plus plus the additional finishes for all the roof up to the roof floor. So we have added those. Okay, so good. First of all, let me check if I included my diaphragm. So first of all, I'll delete these ones. So let me go back to load cases. So Seismic, here, there, yeah. So I think we are done with Seismic loads. So the only thing we are left with is to assign these member loads to the relevant walls and also the parapet. So we'll go and do the same thing to load classes. Add. Going to add Seismic SZ, that is SZ X in the X direction, then add, and then we're going to add Seismic XZ in the Y direction, Seismic SZ in the Y direction, add. Then of course we're going to add the dead load, add, then live load, then add, then the final is wind load. So wind, we're going to go for wind in the Z direction, add, and wind in the X direction, then add, then close. Because the roof is going up to a height of 40.22 meter, and we should start applying wind from a height of 10 meters. So we should apply wind load, because I think they are like in the water slab, there are that fifth floor, okay, that fourth floor. So we should apply wind load. So just go to here, then add Seismic, and in the X direction a factor of 1, then add and close, add Seismic the Z direction 1, then add and close, dead load, add, start by self weight -1, add and close. Remember this one, for Seismic the self weight is assigned automatically, but for load cases we need to assign our cells. So we start by dead load, and also we add again for our unit unit weight. Okay, so go to the member load, because we said that for walls is 9.6. That's now this time negative, don't forget that, in the global Y direction. Then for parapet is 0.4, add. Then we go to flow load. So flow load, we go to, we assign the first one 5.25. Our range was 2.83 to 11.41. Then add. And then we go to, for the roof it was 9, was it 7.9 for the water tank. Now the range is 14.23 to 14.27. then add. Now remember, this one is negative. Now here the direction matters, so we also need to change this. Close. We also need to change this to negative. Edit, it should be negative, so it's acting in the downward direction. Change. Okay, close. Then need to add another flow load. Now I think we have added all the flow loads. This is for water tank, this is for normal slabs. Then we need to go to live load. Now live load, close, add flow load. Now for -4 now, ranging from we said 2.83 to 1.8 now not 8.5. you can just refer from here, 0.56, then add. Then I can check if what I added twice. Close. What about this? So I added it twice. It should not be like that. So I should remove one, delete one. So this is just for live load for the normal slabs, for the room slabs, and then for the roof and the water tank, that is live load, then dead load, and then dead load for water tank. We do the same thing. Add, come here, add, come to load cases, add. Okay, we need to add live load, solve for that, add. Then flow load, then 1.5. Remember, we can just refer here from 11.39, that is the range, to 14.26, and then you can add. Remember the sign, we have not included the sign. Edit. The sign here is very important, which is negative, meaning it's acting a negative direction in the Y range, in the global Y change. Okay, then I'll close. So we have assigned, remember these are usually assigned automatically. Live loads we have all assigned. So wind, add wind load. We're going to add x windward. Range is from 10 to 14.25. remember, don't go past the height of the structure. If you go node to node distance, it will bring errors. So we found that this is 14.2, so don't go past that. So windward x, add, and then -1, also x windward, now in the other direction, add, and then leeward in the this direction, add, and then in the other no, I should first delete this because it should now be indicated in the other. Delete. So I now add to this. So wind z. Okay, now this one is z because the first one you use x. So add. Now the range was 10 to 14.25. Then add. Then negative. And then add. Okay, and then close. Then you can check. Sorry for that. Wait a bit. Sorry for that. So we continue here. That one has been assigned, this one has been assigned, this one has been assigned, and then that one has been assigned. So you can see. You just try shift L, shift X, shift L, shift. Okay, so you can see they have been assigned all of them, although we are not seeing the wind. So you should go and assign this and this. Should assign these. You should first assign the self weight here. Assign to view. Assign. Yes. Now we should assign again for the external walls. So I will go to view, top, and then I will select all the walls with the external, all the beams with the external wall. So I'll go select. I'll go to view, then select that one, select that one, deselect this one, select that one, and then select that one, and then select that one, and then select that one, then select that one, and then select that one, and then of course select that one, deselect that one. This parapet does not have any wall, and we had a wall here, we had another wall here, we had another wall here, then deselect that one, and then you can select, you see the selected objects, then you can go to 3D, then plan. Remember this top part is just parapet. Okay, so I just select again, just select this one. Okay, and then selected objects, and then 3D, so you can see the 3D, then deselect. Then we want to select parallel to X and parallel to Z. Beams parallel to X, beam parallel to Z. Then we can now assign this, assign to the selected. So assign, yes. Also this assign to the, let's select again X, select again Z, assign to the selected, assign. Then we will view the whole structure. Then we will select the top parts. Sorry, view selected object, and then go to the 3D view. Then we will just select the outer beams. So first of all, I need to assign this and this, sorry, and that. We need to assign this, because now that one is not opened. Assign this. Then assign, yes. Then I go to plan view. Now I need to assign the parapet, so I will assign that point, that point, that point, that point, that point, that point, sorry, that point. And then we want to assign this. Select again, these are the parapet, and deselect that one, deselect this and that, and assign that, assign, yes. Then also assign this, assign, yes. Then also to the roof, let me go to the 3D. So also to the roof, so this one should not be assigned anything, so I should delete. Okay. This beam, if I assigned it a load, it should not be assigned. Properties, then loading. Okay, close. Okay, so I included the parapet. So for the roof, select that one, select that one, that one, and that one, then add the parapet. Okay, see, like I assigned a load, it should not assign a load. Properties, loading. So remove select load item. Yeah, I need to remove this. Remove that. remove. Yes. Oh no, let me just leave it like that. Okay, add here, add here, add here, add here. Select that. Going to add assign. Yes. And then here, yeah. Then you go to assign this. Assign. Yes. And I'm going to close it. Then I'm going to display the entire structure. So the other thing, we have now finished assigning our loads, is to come to loading. Then I don't need to add my load combination manually, but if you want to do that, you can just click here, load case combination, and just click here and then edit. But for me, I just need to generate combination. Can use the ACI or the BS code. Just use the ACI. Then I will click generate. Then I will just add, and then I will close. Then I can save my model now. Then we will run our analysis and check for the 0 errors. So remember, it is very important, if you come to loading, it is very important that you make sure that you added the seismic loads first. If you add seismic load after, then you will have error during your analysis. So make sure you add seismic loads first. Okay, and I will close. Then run my analysis, check for 0 error. I want to do concrete design, so I can use the ACI code then and run my analysis. So I should close this, then I remain on that one. It's taking too long. Let me first remove that. Yes, let me first show you. Go here, task manager. It's taking too long. Yeah, we check the license I'm using. I should be using advanced, not any other license. Should change the license to advanced. So I'll go to settings. I will go to task manager. I'm clicking setting again. Okay. In task manager, I need to close this and then check if I'm using advanced, and then redo the analysis, because it is taking too long. It means basically that you are using the standard or the limited version of license of concrete design license. So I will end for this window. Okay, end task. Then I will close this then I will save. Yes, and make sure my load combination have not again disappeared. Then I will go to file, go to file, go to file, then import, and then okay, settings, tools. You have to close this to check the license again. So if that is what, we will have to do it again. And let me confirm. Let me go to open. Then wait a bit. I have all the licenses, so just go back. What I need to do, I should delete all these combinations. Let me first delete. If you see C basically means combination, so let me delete this all these combinations, then use another code, because that code is maybe the load combinations are too much, no, taking too long. Let me delete all the C's for load cases. Okay, I will auto generate, and then I will use the BS. Okay, generate, then add. Okay, then I will go to analysis. I will do concrete analysis. Use BS again. I will use BS code. Sorry. Then maybe that is where there was confusion, because in my commands I had used a BS, so that is it. So now I will run my analysis and save. It should not be taking too long. This is taking too long. If you see it's taking too long, either there is an error or there is an issue in the license. So you should communicate with official Bentley to see how we will solve the issues license. Official Bentley website. Let's give it some time. Hopefully it will finish, but it normally doesn't take that long. But as you can see, there is no warning, no error. Basically, if I want to confirm there is no error, I can just maybe delete the command for design concrete. Okay, can stop delete the command for design concrete. So we'll just analyze without designing the concrete, because if it is taking too long, it is in the process, it's hanging during the concrete design. So let's first try the other way that I was thinking. Taking too long. issue first. Task manager, close this. It's taking too long. I should not be doing that. So I'm just going to close the application, then restart it, and then we're going to see if that is the issue. Then the license, check the license again. The license that I'm using, I should be using advanced license. Close this window and enter and close and should close this, then you start. If it refuses, we just we're going to end it's just going to analyze, it's not going to design, because you can design using a concrete designer or Staad advanced. Okay. My laptop is misbehaving quite a lot. Just try task manager again, because it is hanging and it's supposed to close. So just close that and go in task. Okay. Then I will start it again. Check the license and continue. It basically means, well, probably I'm using the limited version of license. Yeah, that's the problem. So I should make sure I have selected the advanced version. That's how we do it with this software. If it persists, you can communicate with the official website of Bentley, so that you can be able to explain why the software is misbehaving. Right? So they have their own website, you can, and they're very, very responsive. You can talk to them. Right. So please bear with me, it's taking a bit too long. Just close one window, just delete one window and try to refresh it. So we want just to make sure that there are no zero errors. There are no errors actually in our analysis, because if you do not assign the loads in the correct way, there will be errors. or even the correct order. As I have insisted that you must start with seismic loads. In our location, very rare to find someone designing for earthquake pros. It's very hard and very rare. Okay. So let us wait. It's configuring, taking its time. Normally it behaves like that sometimes. So bear with me so that we can do this together. Please don't forget to support my channel, subscribe to my channel, and I will have more good content for you, because trust me, it takes me a lot of effort to create this video. Before I create this video, it takes me a lot of effort. So please, the only thing that I just I'm requesting you is, please don't forget to subscribe. If you like it, I would really appreciate. Okay. So it's finalizing, it's taking its time. Right, done. So I'm gonna check the license. I can see here it's already checked, so I don't know what is the problem. Let me just confirm. Unless we just need to, I don't know, what is this? Okay, I need to use that advanced. Okay, just take those, all of those, accept. Okay, just accept all of those, and just like that. Reopen. And that's how you can see I've taught you how to solve another problem, because instead of going to ask them, for them it's probably that it's maybe a too simple question, but a person who's trying to learn really need to understand what you're doing, and you need someone to be there to assist you, and I'm here. So what? Please subscribe. Alright. It is rechecking license, taking its time because I have changed something, so it needs to restart. And that's how I solved the problem last time. I don't know why doing the same thing today, but maybe unless there's error in my mode, and even if there's an error, it's not supposed to do that. And so we are here. And so I'll add this. Maybe there's an error in the model. Maybe, just maybe. But I will check. I remember there's an error. I added a load to a column. Okay, so I need to go and delete that load. So I just delete that column, then add it, then reassign it. I hope you can see all my licenses are checked, or my primary and my additional licenses. So maybe I should just, yeah, this column might be the problem. We just delete it, then and then I just add a bin from this point to that point, and then I will just assign it. Then property, I select this, no, that one, I need to assign it 0.4 or 0.225, this one. So I select this one, not that one, and then assign to the selected bin, because I thought actually I added a whole load to this column, so maybe it's because of those predicament of mine. And then I can just check the 3D view, and you can see, okay, then I can just save my model, and then I can just do my analysis. If it misbehaves this time, I'm gonna have to just run the analysis without doing the concrete design. We can do the concrete design using advanced, okay? So you don't need to hassle, to struggle, don't need to struggle. Let's start concrete design. Still misbehaving. No, we're gonna have to do that. Okay, let me check the command. I'm gonna have to do what must be done. We have to do what must, and it is what it is. Who selected that? No, me. I don't think so. Not me. I'm gonna have to close this. Then I'm gonna have to remove all concrete design. I will design concrete in another software. Just need to do my analysis, then check if there are errors. Sorry for that, guys. Surely I did not expect it to behave like that. This just caught me by surprise. So I did not expect to do that. So bear with me. So I'll go to loading, go to concrete design. I'll go to concrete design. Oops. I just going to do concrete. Yes, the command I need to delete. This start concrete design. I don't need this. Okay. I will delete this command and all its related. Yes. So I have shown you another trick. Let me now do analysis. So you don't need to do concrete design with this Staad Pro, because at the end of the day you have RCDC. That's the best choice. You just need to do the analysis, then transfer the analysis results, then do the computer design there. Okay, 2 warning. Let me check the warning. See the warning I just do. If they are related to loadings. Okay. Okay, warning is related to if this UBC I analysis has tension or compare. Okay, you see it's not related to loading, so I think and even if it is related to loading, I just okay, in fact that is not a warning, you see, or you can just saying just that I just need to perform analysis every time I make a change, you see. So that's how you do it, guys. So we can, from this we can go to RCDC, then we can design. I can design our columns. Just I'll close this window and come here. Let's design our column. Remember, you need the RCDC software, and see you need two different software to be able to do this. You need RCDC and you need the Staad Pro connect. So without one you cannot do this. Save this, client, viewers, and then engineer Geoffrey. Alright, so VS Code, and we need footings, then create, just design footing. So the rest, you know, you're gonna use the same procedure as the way I will just do now. Then this takes its time, if you don't mind. Okay, let's check. usually takes its time. So you can see it's all about these softwares. Sometimes, you know, an engineer, you learn, you adopt patience in many fields, in many areas. So it's just no big deal, not big deal, just small issue. Just wait some few minutes, and then that is it. It is what it is. Okay. Still reading the analysis model. Please, I am still requesting you, please subscribe to my channel. I'm here. I'll be very helpful. So, and I really appreciate if you subscribe. So consider it is behaving. Maybe I will need to end this video. Even here I've never seen it behave like this. To be honest, maybe RCDC itself is hanging. I've never seen it behave like that. Maybe it's RCDC one. Just give it some like 4 minutes. If you guys just have to end the video and then figure out what is the problem and use today, because it's overhang, that is hanging. Even me, I've never seen it behaving like this. I don't know. I don't know. It's almost done. Almost done. Because this even scares me. Because at the end of this, I'm scared. Scared. And reading the analysis. Maybe it's not able to read the analysis data. Okay. Yes. Then I'll close this. Then close this. Then I will open it. Yeah. No. This named key, we just find it, then we open it. Task manager. I need to close this. And I need to close Adobe. Make my laptop be even slower. And task. Okay. Then open the RCDC. You need this software. Alright. I'm gonna use RCDC. Close that RCDC and then accept. Staad Pro Advanced. So let me go back to configuration. Let me go back to licenses. Yeah, we should use Staad Pro Advanced, then save. And save. And don't show that, then okay. And my file is called key. I'm gonna browse. I'm gonna open another project. Staad Pro. Maybe I go to where I saved my file. Let's see the file location. Right, it's called key. Okay. I should copy this. Copy that. Okay. And should select it. Okay. Cancel. Okay. I need to open and RCDs. New. I was going in the wrong place. That is the file I should open. Then that is design column of views column. Okay. Sometimes these softwares, sometimes it's just like your laptop. Can sometimes frustrate you. You end up learning new things every time you're using your laptop, because sometimes it behaves the way it wants. So not that you have done anything wrong. Sometimes surprises you with certain things that you didn't expect. So hope it will give the model. Or you can just stop the video and then continue another video. I think I will end the video here. We will continue it in another video. Please subscribe. Thank you. My computer today has misbehaved quite a lot.